Assalamu alaikum and good evening, guys. Noha, Yahya, and Zaina. Am I audible properly?
Yes, ma'am. Already.
Point in the last class, and we also learned a point regarding the usage of pressure cooker. Only and Noha and Zaina. You guys need to see the notes, okay?
Sir, your voice is cracking, sir.
Yeah, you have sent me. Is it cracking for all of you? No, Zaina, tell me.
It's cracking, sir.
Sir, it's cracking.
Noha, Yahya, and Zaina.
Ji, sir.
Is the voice now? Am I audible?
Yes, sir.
Yes, sir.
No, it's okay. Thank you. Yeah. So just write a few notes. I hope you have written the definition of boiling point. Then you will write a few notes. First point you will write is boiling point of a liquid is directly proportional to external pressure. Then you will write next point. Due to higher pressure, in pressure cooker, the water inside can attain temperature higher than 100 degrees Celsius. And in short, what is happening? The boiling point of water is increasing. Right? Inside can attain. Therefore, food is cooked faster. In pressure. It's cooked faster in pressure. Next point that you will write is the boiling point of a solvent or a liquid it is inversely proportional to its vapor pressure. Now, please understand this point. If the vapor pressure of a certain liquid is very low, that means at room temperature 25 degrees Celsius, the vapor pressure is very low. Now, when you start to heat it, we have to take the vapor pressure, we have to increase the vapor pressure and take it to 1 atm. Then only it will start boiling. So if the vapor pressure is already very low, we will have to heat a lot and temperature at which it will reach 180 will be higher. Now let's suppose if there is a liquid which is having vapor pressure which is approximately 0.88, so which it is quite higher. So what we can do, we can heat a bit and it will reach 180. So a liquid, if it is having a higher vapor pressure, it will boil easily. Liquid which is having lower vapor pressure, it will boil with difficulty with higher boiling. Make sense, everyone? Yes or no? Please tell me. No, hi, Zaina.
Yes, sir.
No? Okay, this down. Raise your hand once you're done. The initial 2 points, Annapurna, it is the same thing that we discussed in the last class. We did not write anything. So now, right now. Yes, no, I want to say something.
Sir, can you please explain the last point again?
Yeah, sure. So, for example, if you have a liquid A, its vapor pressure at 25 degrees Celsius is 0.2 atm. And we have liquid B, its vapor pressure at 25 degrees Celsius is 0.8 atm. So it is already having a vapor pressure which is 0.8 and 0.2. Now, when you are going to heat it, obviously when you have to boil it, so you will heat it, and as you heat, the vapor pressure will start to increase. So it will be much more difficult to get this 0.2 atm to 1 atm, and 0.8 atm to 1 atm will be easy. That makes sense? Yes or no? Please tell me.
Yes, sir.
I know. So that is why, if with difficulty means, that means you have to heat it a lot. If you want to go from 0.2 to 1 atm and it is difficult, that means you have to heat it a lot. If you are heating a lot, that means the temperature will be higher. The temperature is higher, so the boiling point will be higher. So the vapor pressure was low and the boiling point is high. Make sense?
Yes, sir.
Now, just one more thing to differentiate between the external pressure and vapor pressure. Maybe you are confused regarding that. Vapor pressure is the pressure because of the vapors of the liquid molecules just above the liquid. External pressure is whatever pressure is on the lid. If the external pressure is high, we'll have to put a lot of pressure from inside to shake the lid or to reach boiling point. ठीक है, लेकिन अगर अंदर ही pressure ज़्यादा है, if the vapor pressure inside is itself very high, then we can easily reach 180. चलिए. Now, I hope all of you have written this down. Is anyone still writing? Just say yes. Anyone writing? No one is writing. Okay. Let us suppose we have a liquid A and liquid B. And obviously A will be solvent, B will be solute. And both of these are liquid. And what do? We mix it. And once we mix it, we would need a bigger utensil. And we mixed it. Fine. Now, once you mixed, in this particular solution, we are having both A and we are having B. Let me make this some particular B. So obviously, in the vapor side also, just above this solution that we have just prepared, we will be having two different vapors. We'll be having the vapors of A and we'll be having the vapors of B. Let's suppose the vapors of A, they are certain in amount and they're putting a pressure that is known as PA. Similarly, the vapors of B are putting a pressure, they are giving out a pressure that is P. Now the total pressure of the solution will be whatever pressure is given by the molecules of A plus whatever pressure that is given by the molecules of B. Now the next thing that wait a second, guys. You're not writing, I hope. Anna? Please don't write this. You don't have to write this, you just need to understand this. Okay. Now, and I mean, if you want to write, you can write, but not now. Now you have to just listen. Leave your pen aside in your table and just listen. Is it clear till here? Yes or no? Please tell me. The total pressure above the solution will be the pressure that is applied due to the vapors of A and the pressure that is applied by the vapors of B. Make sense? Annapurna,
sir.
Zaina,
Yes, sir.
Nidya.
Yes, sir.
Now let us see what is PA. What is PA? Can I say that PA will depend on the amount of liquid A we are having? If I have more liquid A, the vapors of A will be also more. If I have less amount of liquid A, the vapors that is formed of liquid A, that will also less, because how we are getting the vapors of A? We are getting the vapors of A only because of the evaporation of the liquid A. And from the vapors, we are getting the pressure. So I can say PA will be directly proportional to chi A, the mole fraction of A, the amount of A that we are having inside the solution. Make sense till here? Yes or no? Please tell me.
Yes, sir.
Now we have a constant now. ठीक है ना? तो PA is equal to, I am just naming this constant P naught A right now. So कोई meaning नहीं है. It does not have any meaning right now. Into chi A. Now, once I have got this equation, we remove the proportionality sign and we got the equation. We got the equal to sign and we put up a proportionality constant. Now we want to define the proportionality constant. What do you want to do? Tell me, guys. क्या करना है? Annapurna, Loha, and Zaino.
Define the
Put a proportionality constant.
Yes, very good. We have to define the proportionality. Yes, here you have got disconnected. Let me just repeat. We were having PA is directly proportional to chi A. We remove the proportionality constant. We put the equality sign, and then we got a proportionality constant P naught. So PA is equal to P naught A chi A. We don't know what is P naught A. P naught A को आप K भी मान सकते थे, but right now I'm taking P naught A because P naught A is taken. अभी K लेंगे, then I will change it to P naught A. That is not good. So that's why I'm just taking P naught A. We don't know what is P naught A right now. We will define P naught A. In order to define P naught A, let's take a case where chi A is equal to 1. The mole fraction of A it is equal to 1. So when the chi A will be equal to 1, the pressure will be equal to P naught A. Chi A is 1. It means that in the solution, we are only having solvent A because chi A plus chi B, it is equal to 1. If chi is already equal to 1, right, then chi B will be equal to 0. Makes sense, yes or no? Please tell me.
Yes, sir.
What about others? Noha, Annapurna, Zainab.
Yes.
Yes, sir.
Yes. So I can say, this P naught A is the vapor pressure of pure A. Make sense? Yes or no? Please tell me. P naught A क्या है? P naught A is the vapor pressure of pure. That means if you take pure A, you don't add any solvent. You don't add any other component. Whatever pressure pure A will be giving, that will be P naught A, and that will be a constant. Make sense? Yes or no? Please tell me.
Yes, sir.
ठीक है. So now we can similarly say that PB will also be equal to P naught B chi B, and overall the equation for P total will be equal to PA, it is P naught A chi A, plus PB, it is P naught B chi B. Now, once we have got this, this is nothing, this is what Rawls also did. This is Rawls law. Okay. This is what? This is Rawls law. Chaliye. Now, if you want to write something, you can write it right now. Otherwise, you can leave it and we will write the Rawls law, जो चीज आपके लिए ज़्यादा important. ठीक है ना? Don't worry. Everything will be there in your notebook. Write the heading, Rawls law. Now, please write. For a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to its mole fraction. Is directly proportional to its mole fraction. And P equal to P naught A chi A
Done, sir.
chi B. I'm sorry guys for that internet connection. Yeah. Can you guys see my screen? And am I audible properly?
जी sir.
Yes, sir.
So your voice is
Okay, so I have written this. My voice is not clear.
no, so your voice is lagging. I think it's my internet connection.
Is it like? Seriously?
Yeah.
Okay.
Mm.
For others, it is fine. Na? Annapurna, Noha, and you're here.
जी sir.
Yes, sir.
Yes.
Yes, sir.
ठीक है, चलिए. So see that when chi a it is equal to 1, p naught a is equal to p. Therefore, p naught a and p naught b are the vapor pressure of pure A and B. Fine. And we can say that P total is equal to P naught A chi A plus P naught B chi B. Okay. I hope I can go till here now. Basic. For numericals, we have to rearrange this a bit. Like this is this equation that we are having write it properly. P total it is equal to P naught A chi A plus P naught B chi B. P naught B chi B. Yeah. Okay. Now we have to rearrange this equation a bit for the cases of numericals, because in numericals it is better to have a bit short of this particular formula. So we will rearrange a bit. We know that chi A plus chi B is equal to 1. Assalamu alaikum, Mariam, am I audible?
Yes, sir.
Yes, Mariam. What happened? You're a bit late.
Sir, I thought the class was at 4:30. Like
लास्ट क्लास में लेकिन हमने तो बोला था ना, नहीं बोला था हमने लास्ट क्लास में? नहीं बोला था मरियम, बोला था ना? आई थिंक यही से हमने पूछा था लाइक are your school still going on or not, and then I said that the next class will be most probably from 4 o'clock, that is 6:30 p.m. Indian time. No problem, it's one class only. You just watch the recording, previous recordings. ठीक है? Okay, Mariam?
okay, sir.
Okay, please hear this. P total will be equal to, what I will do, I will, instead of writing chi b, I will write 1 minus chi a, because chi b will be equal to 1 minus chi a, right? So P total will be equal to P naught a chi a plus P naught b into 1 minus chi a. This will be equal to P naught a chi a plus P naught b. P naught b into 1 will be P naught b minus P naught b into chi a. I will take this P naught B into chi A and I will just put it here. So not much change, you just see. I hope you don't have any problem with this. This is basic middle school maths. Now this will be equal to, I will take the chi A common and I will be having P naught A minus P naught B plus P naught B. P naught A minus P naught B will be in brackets. So this is the P total. Now what is the useful thing here? The useful thing here is that you will be given P naught A, you will be given P naught B, you will be given P naught. All of these things will be given. Chi-A is not directly given. Chi is always given indirectly. Like it means you have been given the amount of solute, amount of solvent, then you have to calculate the Chi-A. So it is better always to calculate one mole fraction and then use it. If we are going to use this particular formula, then in that case, we'll have to calculate Chi-A as well as Chi-B. Both of them we have to calculate. But in this formula, what we need to do, we need to only calculate what? Only we need to calculate the Chi-A. So this is only for what you're going to use is only for the numericals. This is for numericals. The Rawls law that we are going to use for numericals. This particular form of Rawls law, it is used when they are asking what is the write the mathematical expression for Rawls law, then you are going to use this. Okay. Then you are going to use this particular equation. So please write this down, raise your hand once you're done. Please raise your hand once you're done writing. Zaina, just waiting for you. Scroll down, please. Yes, sure. Zaina, I hope this is enough. Let me know once you're done.
Um,
Okay. Understand? Right, next. Graph for Rawls law. Fine. Now this graph, it is something that you may not have seen previously, this type of graph. So please don't write it now. Just listen. And once I'm done explaining, ध्यान से सुनिएगा, like all the explanation, please listen to it very carefully. And once we are done with the explanation, you can write it down. Now, in the graph for Rawls law, here we are going to denote the chi-b. Here we are going to denote mole fraction of solute. It is equal to 0. So mole fraction of solute will be 0. Then थोड़ा बढ़ेगा बढ़ेगा बढ़ेगा, and it will be maximum value of mole fraction will be what? 1. 1 से ऊपर ये हो ही नहीं सकता है, right? I hope all of you know that mole fraction will be maximum value of a mole fraction will be 1. That means number of moles of A divided by only A is present, then it will be 1. Right? That is pure B. And just in the reverse order, we will be having the chi-A. So when chi-B is equal to 0, chi-A, the solvent will be only solvent will be present, and as the solute is increasing, the amount of solvent will be decreasing, and chi-A will be 0 when chi-B is equal to 1. First of all, you have to understand this part. Is this clear, yes or no? When chi-B is equal to 0, chi-A will be 1. We will be having only the solvent molecule. And when we are having only solute, then solvent will be 0. Make sense? Yes or no? Annapurna, Mariam, Nuha, Yahya, and Zaina.
Yes,
Yes,
sir.
sir.
Yes, sir.
पक्का पक्का ठीक है
Yes, sir.
ध्यान सुनिएगा ध्यान से ठीक है now this particular line here if I say this is the pressure and here we are going to denote what here we are going to denote the pressure now tell me at this point chi b is equal to 0 there is no solvent there is no solute molecule make sense there is no solute molecules right you need to say yes or no
sir.
guys please tell me
Yes, sir.
okay that means whatever pressure will be there it will be because of what is present right now if solute is not there then what is present
Solvent.
what is present
Solvent.
so whatever the pressure will be it will be because of
Solvent.
solvent and if we have that means we are having pure solvent when we have pure solvent what is the pressure we have just seen what do we denote it by yes. The vapor pressure of pure solvent vapor pressure of pure A is given by please turn the mic on correctly if your guys are using spacebar and trying to speak I'm not able to hear anything I saw Zaina turning her mic on I saw Noha turning her mic on but I did not hear anything I think you gave some answer but I was not able to hear guys tell me what is the vapor pressure of pure A
P naught.
P naught very good yes Zaina and Noha you're answering the same thing
Yes, sir.
Yes, sir.
so you have to turn the mic on properly don't use a space bar please this is something that I have been telling for so many times so at this point there will be some pressure and that pressure will be because of what A and we will call this point P naught A okay similarly if I look at this part where chi b is equal to 1 and A is equal to 0 we are having pure B at this point P naught B will be the pressure there will be some pressure and it will be equal to P naught B. Now we have just taken as reference that P naught A is less and P naught B is more it can be completely opposite also P naught B यहाँ पे भी हो सकता है there is no I mean we are not taking any particular case of A and B generic hai this is P naught B fine now let us see what is going to happen at this point when the amount of B it is equal to 0 the pressure due to B will also be equal to 0 because there is no B molecule if there is no B liquid how can there be any B vapors but as we are going rightwards, the amount of B is increasing. And as the amount of B is increasing, what is going to happen? The pressure due to B will also increase. And you will see a steady increase in the pressure due to B. Now, this particular line, it is representing the pressure due to B. Similarly, at this particular point in the right side, the amount of A that we are having is equal to 0. So the pressure due to A will also be equal to 0. And as we move leftwards, as we are moving leftwards, the amount of A is going to increase and we will reach P naught A. Harsha, were you on the impression that the class is at 7 p.m. Indian time
Yes, sir.
or 4:30 KSA? Did you not get an updated message? Like what was the time on the message?
Yes, sir, I got it. I was outside, so I wasn't able to check.
Oh. Right. So this is what these are the two lines. What is this first line? This is representing what this is representing. Pressure due to B. This line here it is representing the pressure due to E. Now when we are going to add both of these things, for example, at this point, the pressure due to B is this much. That means this much units. 1, 2, 3, whatever it is. Pressure due to A is this much. This whole unit. And when you add both of these things, you will get a point somewhere here. Right? You'll get a point somewhere here. And if you add both of all of these points you are going to add, then you will get a line which will look something like this. It will go from P naught A to P naught B. Now, what this the top line representing? The top clear this. Just need to clear this part and this part. So this is representing the P total. It is equal to P naught A chi A plus P naught B chi B. Does this make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Please copy this down. Please copy this down now. Make this dotted or dashed line at least. Waiting for Annapurna, Noha, Harsha, Yahya, and Zaina. Raise your hand once you're done. Waiting for Noha. Actually, waiting for Noha. Just Noha, just waiting for you. Raise your hand once you're done. Please see it, please. Write the next heading. Composition in vapor phase. So let us see. We had this type of solution in which we are having A and B. Right? Both of them are what? Both of them are liquid. Both A and B are what? Liquid. Now, here we are having, this is PA and this is PB. That is the pressure due to A and that is pressure due to B. Obviously, here also we'll be having mole fraction of A and B. So in the vapor phase, we are, okay, where we are not in the liquid phase, we are at the vapor phase. So there will be some amount of A vapor, there will be some amount of B vapor, and those mole fractions are represented by YA and YB. We cannot use chi A and chi B now because chi A and chi B is used for the liquid, the solution phase. In the vapor phase, we are having some amount of A vapors, and the mole fraction of that will be YA, the mole fraction of B will be YB. Now, there is a very unique relationship. For example, if I want to calculate what is YA, YA will be equal to the number of moles of A divided by number of moles of A plus number of moles of B. Now, number of moles of A plus number of moles of B, I can write this as the total number of moles of all the gases. Like whatever gas is present, all the number of moles of gas. So now number of moles of gas divided by number of moles of the total moles of gas. Now, Na and then we have Nt. You must know this equation. PV it is equal to nRT. Do you guys know this equation?
Yes, sir.
Yes, sir.
PV is equal to nRT, right? Now please see. Here we are having number of moles. Here we are having number of moles. So number of moles, it is equal to how much? This will be equal to PV upon RT. Make sense? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Now, in that case, I can write NA will be equal to the pressure due to A, because the volume, whatever it is, the volume will be the constant, whatever volume the whole thing is occupying, into V divided by RT, divided by the total pressure P total into the volume divided by RT. If you see here, RT and RT will cancel each other. Why? Because R is constant, T is temperature, temperature will be constant, whether you are taking A or you are taking A and B both. The volume is also going to be the same. It is equal to V and V. So those things will also cancel and you will get YA. It is equal to PA upon PT. And from here, you can get this is the equation that you can get for what? The mole fraction in the vapor phase for YA. Similarly, YB will be equal to the pressure due to B divided by the total pressure. This will be the mole fraction of B in the vapor phase. The partial pressure due to B, partial pressure of this PA or PB kahan se aayega? PA will be equal to P naught A chi A. From here you will get PA and P total. How will you get P total? Will be equal to P naught A chi A plus P naught B chi B. Make sense? Please write these equations. We will do a question. Raise your hand once you're done. Waiting for Noha and Zaina. Guys, I'm going to give you a question, but I'm going to change some values in that. Okay. I'll be changing the values only for the ease of calculations because I just want to test the concepts, not how good you are at multiplication. So I have also given the molar masses, okay, because molar mass is available in the board examination. They always give you the molar mass. Vapor pressure solution is mixed by 25.5 gram of CHCl3, okay. Not 25 gram, 25 grams only. We are going to take that is now. You have to take 239 gram of CHCl3. Okay, and we will not take 40 grams 40 ग्राम्स नहीं लीजिएगा आप, 255 grams. 255 grams of CH2Cl2. Now do the calculations. So I have given these values because it will be easier for you to calculate the number of moles. सवाल क्या है? Vapor pressure of a chloroform and dichloromethane at 298 Kelvin are 200 mmHg and 415 mm. First of all, once you see a value, ठीक है, 200 mmHg, 415 mmHg, you need to now tag this value. Tag का मतलब क्या होता है? You need to put a name to this value. What is 200 mm of Hg? It is the vapor pressure of chloroform. So that means we are getting the P naught of CaHCl3. It is equal to how much? It is equal to 200 mmHg. Pressure है ठीक है fine, mmHg. All of these will be in mmHg. It will not be a problem. Then we have P naught of CH2Cl2. This is given as 415 mmHg. Fine. Calculate the vapor pressure of the solution. Calculate the vapor pressure. That means they are asking P total. Rod's law, because both of these. Acha, how do we know, sir, Rod's law? One question that you will be asking after the end of this chapter, sir, how to know whether it is Henry's law, Rod's law? Then you will learn about relative lowering of vapor pressure. It is relative lowering. How will we know? See here. If they have given the P naught of A and B both, that means both of them are liquid. Both of them are volatile. Both of them are going to give you vapors. Both of them are having vapor pressures in their pure form. Solid cannot have vapor pressure in their pure form. If you are having solid, the thing that we are going to learn later, relative lowering vapor pressure, in which we add solid into liquid, right? Now, this case is what liquid plus liquid. Why? Because both of these are going to have what vapor pressure. Okay. Now, by mixing this much. So in order to have the P total, you need to calculate the chi-A and chi, or just need to calculate the chi-A and use that one formula. Then and calculate the mole fractions of each component in vapor phase. We have just seen the vapor phase formula also, right? So please try this. आराम से कीजिए, ठीक है? First thing that you will do is calculate the number of moles of CHCl3, and you will tell me what is the number of moles. अच्छा यहाँ पे let me write one more thing here. That is the given mass. The mass of CHCl3, it is equal to 239. The molar mass of CHCl3, molar weight, it is equal to how much? 9.5. 9.5. For this, the mass, it is equal to 255. The molar weight, it is equal to 85. Okay. So you will calculate the number of moles from here. Number of moles of, let us take this as A. Number of moles of B, let us take this as B. Okay. Please calculate. Calculate the number of moles. Once you are done calculating the number of moles, you will calculate the chi-A. Once you have calculated the chi-A, you will calculate the P total. Please let me know once you get the mole fraction of A. Nobody got mole fraction of A till now.
So is it 0.4?
Oh, number of moles of A, how much did you get?
A number of moles 2,
2. And for B,
3.
3. ठीक है तब 3. 3 if you got then it is clear. Mole fraction of A will be equal to 2 by 5. Right?
Yes.
2 by 5 कह रहे थे ना?
Yes, sir. 2 by 5.
ठीक है, 2. Then you can calculate the P total, right? Yes or no?
Yes, sir.
Constant until here, guys. You can do P naught P plus chi A into P naught A minus P naught B. Or the other way around, however they have written. So P naught B, it is equal to 415 plus 2 by 5. 2 by 5 is 0.4. But 2 by 5, 2 by 5 ही रहने देते हैं. P naught A minus P naught B. P naught A is 200 minus P naught B is 415. Two by 5 multiplied by, this will be equal to how much? 185. No, not 185. 215 minus 215. This will be in minus by the way. Zaina, तो 415 से तो कम ही होगा ना P2.
जी
I
सर
think आपने
माइनस.
इसको positive ले लिया. Minus 215, right?
यस सर.
And 415 plus 2. Now we can cancel this also. So this will be 4 and 15, that is 3. So minus 43. So 2 into minus 43. 2 by 1 हो जाएगा into minus 43. So we can have now P total is equal to 415 minus 43 cut twice 86. Equal to 329. That will be the P total. This is the mm of Hg. Because all the quantities are in mm of Hg. This is the P total we have got. Okay. Next, we have to calculate what the mole fraction or the composition in vapor phase. So composition in vapor phase के लिए क्या करना है? बहुत आसान है. YA will be equal to PA by P total. PA by P total. PA कितना होगा? PA will be equal to the P naught, that is equal to 200 multiplied by 2 by 5, that is the mole fraction. Well, then P naught A chi A divided by P total. This whole thing will be divided by 329. So this will be equal to, can cancel this as what? 40. 42 is 80. 80 upon 329. And YB के लिए आपको कुछ फॉर्मूला इस्तेमाल करने की जरूरत नहीं है. You can just do 1 minus 80 upon 329. So this will be equal to how much? YB will be equal to 329 minus
329 minus 80, sir.
minus 80. Yes. It will be 249. 249 divided by 320. Okay, that is the mole fractions. Please copy this down, those who have not done. I'm waiting for Annapurna, Noha, Yahya, and Zaina. For Annapurna, Noha, and Yahya is done, no? Yahya?
Ji, sir.
Just waiting for Noha now. Noha, this made sense to you? Yes,
Yes,
Noha, you
sir.
understood?
Done, sir.
Done. Fine. Let us do another similar question. Sir, YA and YB values are mole fractions of the vapor pressures, right? No. Yeah, Zaina, mole fraction of vapor pressure, तो मतलब it will not make sense, ना? Mole fraction of vapor pressure कैसे हो सकता है? ठीक है? So YA and YB are the mole fractions of A and B in vapor phase. जो हम लोगों ने यहाँ पढ़ा. Vapor phase में mole fraction of A, vapor phase में mole fraction of B. Make sense, Zaina?
So what is chi A and chi B?
Mole fractions of A and B in the solution. Got the
Okay,
difference?
I got it.
Okay. Okay, now let's do one more question. So this is, I mean, board has never asked this type of question. That is more mole fraction of the composition in vapor phase. But since it is there in an this question is there in NCERT, we have to discuss it. Okay. And it is always better to know the concept if there it is in the NCERT. So try this now. This is a bit easier. The only problem you will be having is the molecular formula of molecular weight, molar mass of heptane and octane. So for that, I will ask you guys to use the knowledge or information that you receive in the 10th standard. Heptane, that means we are having C7. Number of hydrogen you will write. Octane means C8. Number of hydrogens you are going to write. The mass of carbon, you know, the mass of hydrogen you also know. So first thing that you are going to give me is the mass of the molar mass of heptane. कितना होगा आप बताइएगा. You will tell me in the chat. This is the A part that you have to tell me. B part is molar mass of octane. See, I mean, you will also understand, you will also agree with me. These are the hurdles that you are going to face in the examination, because you guys are not going to take care. You guys are not going to be very serious regarding the molar masses. Okay, and heptane or octane is something that if the board it does not give you the molar mass, then you cannot even ask them, because heptane you should know the formula, octane you should know the formula. Mass of carbon and hydrogen, at least they will be expecting you to know the masses of elements till 20 atomic number, है ना? तो वहां तक तो at least they are expecting. So right now you have to calculate the molar mass of heptane and octane. Okay, generally they give you, for example, कहीं आगे MgSO4, for that they are going to give it to you. ठीक है, but be ready for the words. Heptane and octane कम से कम आपको आना चाहिए. ठीक है. So first of all you will tell me A and B, and then you will proceed to the question. Now it is saying heptane and octane form an ideal solution. When they are saying they form an ideal solution, this is just another way of telling that they follow Raoult's law. Okay, that they follow Raoult's law. What would answer? No, molar mass. Molar mass. Got a few answers. Yes, Zaina, that is correct. Yeah, that is correct. And Mariam, yes, correct. So C7, what will be the value of hydrogen? It will be 16, right? Yes or no? H,
Yes, sir.
2n plus 2, right? So 7 to the
Yes,
14
sir.
plus 2, that is equal to 16. And 8 will be equal to 16 plus 2, 18, right?
16.
So
18.
this, yeah. So this molar mass for heptane you will get that as 100. For this you will get it as 114. Okay, once you get for heptane, you can also get for octane very easily because difference between heptane and octane is only of what? CH2. Like in the homologous series, if you remember in 10th standard, the members of homologous series, they differ by CH2, 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 and CH2. Okay, so you have got the molar mass. Now you can do the question. Okay, so even though generally students, they don't take care of this particular term. Please try this question now. हो जाएगा ना? The vapor pressure of two liquid component under which what will be the vapor pressure of the mixture? हो जाना चाहिए 26 grams and 35 grams. The answer that we'll be getting will be in kilopascals. Will you guys take 2 more minutes and then I will explain this. Okay. Just 1 more minute, guys. Sayana has got the answer. I think that is correct, Sayana. That's on the ballpark. The range is correct. This would require a bit of calculation, I guess. That's why it's taking time. Okay, guys, let me just solve this for you guys. Can you guys send me whatever you have done, by the way? You can let how much you have done. Please don't do anything else right now. Just take a photo and send it to me. Mariam, Annapurna, Naha, yeah, and Zaina, you also. Just need to see your calculations. Got it from you. Yeah. I hope you have done a bit more.
जी सर अभी कर रहा था प्रॉब्लम सॉल्व।
अच्छा, इतना ही किया आपने अभी तक या फिर और कुछ किया इसके आगे?
तो सर पी नेट निकाल रहा था मुझे पी टोटल।
Can you send me the other page also then?
ठीक।
Is 0 in Noha mistake है 0.26 plus 0.3. Noha 0.26 plus 0.3 कितना होगा? See Noha?
Yes, sir. I saw the mistake.
Okay, I think I have got from someone else also. Send it to me. 0.56, 0.46, 0.54. That is fine. That is correct. Okay, very good. You could have kept it 13/28, then it would have been easier for the calculation part. Okay, see here, guys. What we need to do is we have got the molar mass. We will get the number of moles of heptane in octane. The number of moles of heptane, it is equal to 100 upon not 100, my bad. Kitna heptane? 26. 26 upon 100. Number of moles of octane will be equal to 35 upon 114. So we'll get the values. This value will be equal to 0.26 and this will be number of moles of octane will be approximately 0.30 है ना 0.30 या 0.31 आप दोनों में से कुछ भी ले सकते हैं 0.30 and the mole fraction of A, sorry not A, let's take heptane, तो heptane मुझे H mole fraction of heptane will be equal to 0.26 divided by 0.26 plus 0.3, which will be equal to 0.26 divided by 0.56. Now this can be reduced approximately 26 upon 56. It will be 13 upon 28. This is the mole fraction of H. You can also calculate mole, but we don't need the mole fraction of by the way. Okay, but still, if you want to take, you can take it. Mole fraction of octane will be equal to 1 minus 13 upon 28, which will be equal to 28 minus 13 upon 28. Okay, so 28 minus 13 we need to do. Just 15 upon 28. Right, then we have P total is equal to, now you can, since you have calculated both the mole fractions, you can have this formula P naught H chi H plus P naught O chi O. Heptane is how much? Vapor pressure of liquid components are itna. Heptane ka 105.2. 0.2 into mole fraction of heptane is 13 upon 28 plus P naught O octane का है कितना 46.8 into mole fraction is 15 by 28. So if there is some calculations that you can do here. So, you can do some approximations, but sent me. नहीं इतना वैल्यू नहीं है 65 आ रहा है आपका 65 नहीं है कुछ आपने गलती कर दी है इसमें you need to check this I mean this would require a lot of calculations ना तो इसको हम छोड़ते हैं इसको नहीं करते हैं I think that formula our P total is equal to P naught लेते हैं किसका octane का plus mole fraction of 15 into P naught of 15 minus P naught of octane. ठीक है इससे कैलकुलेट कर लेते हैं P naught of octane will be equal to what vapor pressure of octane is 56.8 plus heptane mole fraction is 13 upon 28 and P naught of heptane is 105.2 minus 46.8. This will be 46.8 plus 13 by 28 multiplied by minus 46. So it's 58.4. Okay, now just you need to multiply these values. 13.28 का आपको कितना मिल रहा है? Approximately 0.5 के आसपास मिल रहा होगा ना? What value you are getting? 0.45 13 by 28. .46. Plus 0.46 multiplied by 58.4. It's coming out to be 73.66. Kilopascal will be the unit. Kilopascal will be the unit. Okay. After this, you just write next topic, a very small topic. Those who are not done, you will complete this in your home. The calculation part and everything. Leave some space and please write Rod's law and Henry's law. Rod's law and Henry's law. Okay. Now, Rod's law and Henry's law, these are very interesting. I mean, we can say that Rod's law is a special case of Henry's law. How? If we see the the pressure due to B, it is equal to P naught B into chi B. Very similarly, the pressure it is equal to Kh into chi b in the case of Henry's law. Now this P naught B, it is what? It is the vapor pressure of pure B. Also, one more thing that you can understand, if the P naught B, it is very high. The P naught B is very high. That means the liquid, it does not want to stay in liquid phase. It want to easily escape out to vapor phase. That is why if it is having vapor pressure high, you have more vapors. How can we have more vapors? We can have more vapors if the liquid is easily vaporizing. It is getting away from the liquid state very easily. Very similarly, this KH also we have seen that this KH, it also tells about what? It tells about the escaping tendency. It tells about the escaping tendency. And that is why it is said that Rod's law is a special case of Henry's law where, rather, in which will be a better word, in which KH becomes equal to P naught or P naught B. Whatever you want to take, you can write any one of them. Both of these main part kya hai yahan pe? The KH, it is very much relative to, or we can say it is very similar to the P naught B part. Please copy this down. Is everyone done writing? Annapurna, no. Yeah, and Zainab.
No, sir.
Okay, please write.